How to choose right database? There are several common categories of databases, each designed for specific use cases. When choosing the right database, you will want to consider factors like the type of data you are dealing with, the scale of your application, the need for flexibility, performance, performance requirements, and more. Here are some common database categories and considerations for choosing the right one. Relational database (SQL). The, these databases use SQL, structured query language, for defining and manipulating the data. They are based on the relational model and use tables to store data. Examples: MySQL, PostgreSQL, Oracle Database, SQL Server, SQLite. Best use cases: best for applications where data is highly structured and relationships between entities are clearly defined. Commonly used for transactional systems such as e-commerce platforms, banking systems, and more. No SQL databases. NoSQL databases are not non-relational and can store and retrieve data that is not in a tabular format. They are designed to be more flexible and scalable. Example: MongoDB, Cassandra, Redis, Couchbase, Amazon DynamoDB. Use cases: ideal for applications with large amount of unstructured or semi-structured data, such as social media platforms, IoT, Internet of Things applications, real-time analytics, and content management systems. Graph databases. These databases are optimized for storing and querying graph data, where relationships between entities are crucial. They are they use graph structures with nodes, edges, and properties. Example: Neo4j, Amazon Neptune, ArayGoDB, Tiger Graph. Use cases: perfect for applications where the relationships between data points are as important as the data itself, such as social networks, fraud detection, recommendation systems, and network analysis. Time series databases, specifically designed for handling time series data, where data points are indexed and sorted based on time. Example: InfluxDB, TimescaleDB, Prometheus. Use cases: ideal for applications dealing with IoT sensor data, financial market data, monitoring, and the observability. Any other use case where data points are recorded over time. Document stores. Dis- these databases store data in a semi-structured format using JSON or BSON documents. For example, MongoDB, Couchbase, and Firestore. Use cases: suitable for applications with complex and hierarchical data structures such as content management systems, e-commerce platforms, and mobile app backends. Factors to consider when choosing a database. First, data model. Consider the structure and nature of your data. If it's highly structured and relational, a traditional SQL database might be best. If it's unstructured or semi-structured, no SQL or document stores could be more suitable. Scalability. Determine if your application needs to scale horizontally, adding more server, or vertically, upgrading server resources. NoSQL databases are often more scalable horizontally. Performance. Evaluate the read and write pattern of your application. Some databases excel in read heavy scenario like reporting, while others are optimized for write heavy like logging. Consistency. Consider the level of consistency your application requires. Relational databases typically offer strong consistency, while some NoSQL databases offer eventual consistency. sacrificing immediate consistency for scalability. Complexity versus simplicity. NoSQL databases can often be simpler to set up and use, but they might require more application logic to handle relationships and transactions compared to relational databases. Community and support. Consider the community around the database, availability of documentation, tutorials, and the level of support you might need. Cost. Factor is not Factor in not just the upfront costs but also ongoing maintenance, licensing, and scaling costs. Security. Evaluate the database's security features such as authentication, authorization, encryption, and compliance with industry standards like GDPR for personal data. Use case. Ultimately, the choice often comes down to the specific requirements of your application. Understanding your use case, data model, scalability needs, and performance requirements will guide you in selecting the appropriate database. By considering these factors, you can choose a database that best aligns with your application's needs, ensuring efficient data storage, retrieval, and management.